Okay, we're going to look at two more examples discussing other types of motion for simple harmonic motion. In this example right here, we're talking about a particle movement where we have something that is moving uniformly around a circle that has a radius of 2 units with the given speed down here. And I want to find out what the equation is. Okay, so if I have just a circle here, okay, I got my circle. I know that I have a radius of 2 units. Okay, so if I start right here at 0, if I start at 0 and then I were to move around my circle, then that's where my harmonic motion comes in. So if I'm starting at 0 in this 0 position, then I'm going to use the equation for sine. So I'm looking for st is equal to a sine angular speed times t. Okay, so sine because I'm starting at 0. And I know that I have a radius of 2 units, which means when I move around, the maximum height this is going to give me as I move in this direction, the maximum height is still going to be that radius of 2. The minimum is going to be down here and still have 2. In other words, because the radius is 2, that's also the amplitude. Okay? And then we're given what the angular speed is. That's 2 radians per second. So we can come up with the equation that says s of t is equal to 2 sine 2t. Okay, so there we determined the equation. We know what the amplitude is. And now what about the period? Okay, so the period is supposed to be 2 pi over w, which is 2 pi over 2. So the period would be pi. And then the frequency, remember the frequency is the reciprocal of the period, so it would be 1 over pi rotations per second. Okay? Alright, so there's an example of a particle movement around a circle. Now let's look at a pendulum motion, like in a clock, right? We have the length right here of the pendulum. It says here that that we have this problem right here. What is the period and the frequency of the oscillation of the pendulum that has a length 1/2 foot? Okay, well they're going to tell us that the period is equal to this formula right here. 2 pi times the square root of L, which is the length of the pendulum in feet, over 32. So I think we could probably figure this out. If we know, if we're looking for P, and then we're also looking for frequency. So P is given by 2 pi times the square root of L, where L is 1/2. Okay, 1/2 over 32. Okay, and just so long as we're clear, this is L. Now, we're going to simplify this a little bit further, and we say 2 pi times the square root of, well, if this is 1/2 divided by 32, that's the same thing as 1/2 times 1 over 32. Because if I divide by 32, I multiply by the reciprocal. Now, see where I'm going here? 2 pi times 1/2 times 1 over 32 is 1 over 64, which gives me 2 pi times the square root of 1 over 64 would be 1/8. Okay? Or in other words, 2 pi over 8. And we simplify that down and we get pi over 4. So the period is equal to pi over 4. The frequency would be the reciprocal of pi over 4, so just 4 over pi. Okay? Okay, so there's two more examples showing harmonic motion in something other than a spring using particle movement and pendulum movement.